Again, I'm presented with an absolute value equation that I need to solve. So my first step is still going to stay the same as first step every other time. I need to isolate the absolute value bars. So I do that by adding 10 over. So when I've isolated, I get the absolute value of 9 minus 2x equals 3x plus 10. No combining since they aren't like terms. Now this doesn't fall into any of our other situations. Remember, if the absolute values equal to positive, there was 2 solutions. Absolute values equal to negative, there were 0 solutions. Absolute values equaled 0, there was 1 solution. I don't know what these absolute value bars equal because it's not just a constant on the other side. So it just puts me into a different category of the absolute values equal variable. And when the absolute values equal variable, we need to write 2 equations and check. We're going to check if the answers we get are actually viable answers. So I'm going to follow the same pattern I did in terms of breaking this up. I'm going to break it up into 2 equations. The first one is going to be everything I see, 9 minus 2x equals 3x plus 10. Everything I see except the absolute value bars. So in other words, the inside has to equal the right-hand side. And the other equation is going to be, I keep the left the same, 9 minus 2x. This equals, normally I would take the negative of the right-hand side. Well, here I'm just going to flip all the signs. So this would be 3x minus 10. Originally it was 3x plus 10, so negative 3x minus 10. And these are my 2 equations. They're both just linear equations I need to solve. So working on the left-hand side, if I add the 2x over, I get 5x. Subtract the 10, I get negative 1 equals 5x. Divide by the 5, negative 1/5 equals x. And that's a possible solution. I have no guarantee that he's actually a solution yet. I'm going to have to check him. Let me get my other possible solution. I'm going to add the 2x over. I get negative x minus 10. Add the 10 over. 19 equals negative x. So negative 19 equals x. Again, he is a possible solution, but I don't know anything until I check them. So whenever I go to check, and do that in purple, checking is my way of saying, are these actually solutions, or are they just mathematical possibilities that aren't solutions? And where I'm going to check is I'm going to check in the isolated step. I could check in the original, but I prefer to check in the isolated step. And I'm just going to plug them in and see if they work. So first one I'm going to check is negative 1/5. Let's plug them into both sides. I get 9 minus 2 times negative 1/5, and that equals 3 times negative 1/5 plus 10. It's really just a matter of using a calculator or doing some math. I'm not going to show all of that, but if I do all the math, I get 47/5, or its decimal approximation. In this case, an actual decimal because it's terminating. And on the right-hand side, I get 47/5. So the absolute value of 47/5 equals 47/5. That's something that I can agree with. When I check him, he checks, so I come back over, and that makes negative 1/5 a solution. He worked when I plugged him in. I have one more thing I need to check. Let's check the other possible solution. And that one was x equals negative 19. So let's plug it in both sides. Absolute value of 9 minus 2 times negative 19 equals 3 times negative 19 plus 10. It's a decent amount of work, but it's going to show us if we're right every single time. So on the left-hand side, you get the absolute value of 47, which is positive 47. And on the right-hand side, if I plug that all into a calculator, I get negative 47. And a red flag kind of goes up here because I know that the absolute value of 47 does not equal negative 47, which means that he does not check, which means ultimately, even though this was a possible solution, we're going to label him as what's called extraneous. In other words, extra, a solution that looked like a mathematical possibility but doesn't actually work when I plug it back in. Now, one note about extraneous solutions. For extraneous solutions, you could have one solution being extraneous, like we did in this problem. They could both be extraneous, or neither could be extraneous. So just be careful and make sure you go through and check both of them, just like we did right here, and see if they work or not. That extra time is going to ensure that you actually get an accurate answer.